In this lesson, we're going to talk about the multiplication law for probabilities. To motivate this, I'm going to start with an example that maybe at first doesn't even look like it has much to do with probability, but I'll explain the connection as we go along. So in this example, we're given some data about the students in a particular school, and we're told that 25% of them are taking higher level maths, 40% taking higher level English, and we're told that of the ones that are taking higher level maths, so just of those ones, 75% are taking higher level English as well. And then we have a couple of questions to answer about the probability of a randomly chosen student taking both higher level subjects, and we have a true or false. Right. So how does this all relate to probability? Well, let's start off by trying to represent this situation with a Venn diagram. So let's say that this box represents all the students in the school, and can we somehow represent this information that we're given in the Venn diagram? So we're told that 25% of them are taking higher level maths. So I can section off a part of this box, and 25% is a quarter, so it kind of makes sense to maybe take a quarter of this box and say that these are the maths students, or the higher level maths students. So I'll call that M. So everything in the red shaded area, those are the students that are taking higher level maths, and everything outside that represents the students that are not taking higher level maths. And then we're also told that, we're told about the higher level English, and we're told, as well as the higher level English, we're told that of the ones taking higher level maths, 75% of them are taking higher level English. So I'll go to that piece of information first, right? Of these red students in here, 3/4 of these red students are taking higher level English. So maybe I'll use green to denote the higher level English ones. So now I basically want 3/4 of this red area to be higher level English, right? So I'll put that in green as well. So E means higher level English. So 3/4 of the red area is shaded green. And then we're also told that of the entire student population, 40% are taking higher level English. So we need some extra green stuff out here to make the total green area up to 40% of the whole. So we have some extra green stuff out here. Right. So we have a green area and a red area, and they overlap in this L-shaped region in here. And these represent the students taking higher level English and higher level maths. Okay, so that's kind of a Venn diagram representation. Now, we'd also like to take this information and interpret it in terms of probabilities, because that's what we want to talk about in this lesson, is probability. Okay, so let M is the event that a random student is taking higher level maths. So I'll just write HLM for higher level maths. And so E is the event that a random student is taking higher level English. So HLE, higher level English. So now this information that we're given, what does that mean in terms of probabilities? Well, the probability that a random student is taking higher level maths is 0.25, because 25% of the students are taking higher level maths. So if we choose one randomly, the probability that we get one inside the set M is 0.25, and the probability that we end up inside the set E is 0.4, 40%. Now, what do we want to do? We want to calculate the probability that a randomly chosen student is taking both higher level English and higher level maths. So what we want really, and I'll use another color, it gets a bit messy here, but we want to look at this L-shaped area here, which I've outlined in purple, and we want to know what fraction of the total is that L-shaped area. So we know that the L-shaped area is 3/4 of the red area, and we know that the red area is 1/4 of the total. So what proportion of the total is the L-shaped area? So what we want is the probability of M intersection E, the overlap, right? Or the probability that a randomly chosen student is taking higher level maths and is taking higher level in English. So remember, intersection really corresponds to and in this context. And so what do we know? We know that as a proportion of the red area, that's 0.75. And the red area is 1/4 of the total. So really this is going to be 0.75 times 0.25. It's going to be 3/4 of 1/4. And what's that? Well, let's write it as fractions. That's going to be 3/16. So the probability of M intersection E, or M and E, is 3/16. So what do we really do here? I mean, we'd like to generalize this, so we really want to try and pick out what we actually did in this calculation here. This 0.75 here, what is that? That represents the probability of E given M. Right? Remember that that's the proportion of the higher level math students that are taking higher level English. That's where that 0.75 came from. And the 0.25, that's just the probability of M. That's the proportion of the total number of students that are taking higher level maths. So really what we got here was that we got this equation that the P of M and E is P of E given M times P of M. And really that is the multiplication law. So let me write that down and put it in a box. So here it is. Here's the multiplication law. The probability of A and B is the probability of B given A times the probability of A. And we saw that in action there in this example. Instead of A and B, we had M and E. And we saw that the probability of M and E was 0.75, which is the probability of E given M, times 0.25, which is the probability of M. Right? So that allowed us to calculate the probability that a student was doing both higher level maths and higher level English, given the information that we're given in this problem. Now let's look at part B of this problem. So I'll scroll up for a second. So we're asked to decide whether this statement is true or false. A randomly chosen higher level English student is more likely than not to be taking higher level maths. So in terms of probabilities, what are we asking here? Well, we want to look at the probability that a student who is known to be taking higher level English is also taking higher level maths. So really what we want to work out there is a conditional probability. We want to work out P of M given E. So let me jot that down there. We want to work out the probability that a student is taking higher level maths given that they're taking higher level English. So we want this conditional probability here, P of M given E. So now let's see if we can use our multiplication law to calculate this conditional probability. So what do we want? We want the probability of M given E. Now let's see. Well, the multiplication law tells us, let's put it over here, it tells us that the probability of M intersection E is going to be the probability of M given E times the probability of E. So that's slightly different to the one that we used before. We've turned it around now. In this use up here, we had the probability of E given M, but we can equally just interchange the roles of M and E, and we can use it this way. And now the point is that we know what this is now because we've just calculated it. We know that this thing here came out to be 3/16. Because we calculated it just up here, right? Probability of M intersection E is 3/16. And in the statement of the problem, we're told what the probability of a student taking English is. We're told that 40% of the students take higher level English. So we know that P of E is 0.4. So in this equation here, we have 3 quantities and 2 of them are known. So we can solve for the unknown, and that's what we really want, right? So the probability of M given E, Well, if we just divide across by the probability of E there, we get the probability of M intersection E divided by the probability of E. And now we know both of those things there in that ratio. We know that this one is 3 over 16, and this P of E here is 0.4, which is 4 over 10. And what is that? That's 30 over 64. Just simplifying the fraction there. And 30 over 64, well, you can either just see this yourself, or you can take out a calculator and check that that's less than 0.5. 30 is a little bit less than a half of 64. Right? 0.5 is the same as 32 over 64. So 30 over 64 is less than that. So that means that this event, the M given E, is less likely than not. So what was the question? The question was to decide whether this statement is true or false. A randomly chosen higher level student is more likely than not to be taking higher level maths. Now, what we've done is reformulate this in terms of probability. We were looking at the probability of a higher level English student taking maths, and we found out that this probability, we've calculated this, it's less than a half. So that means that the student is not more likely than not to be taking higher level maths. So this statement here is false. So the correct answer to B is that the statement is false. Okay, so that's an explanation of the multiplication rule and an application of it to this particular problem.